Hey, boys and girls, and today what we're going to do is we're going to do some review. We are going to be reviewing word problems, partitioning, which we've been talking about the past couple weeks, and time. So I want to go back over a couple of those things with you just before you do your Seesaw activity, which will also be review. So you will be reviewing time, partitioning, and some tricky word problems. So let's go ahead and get started. I'm actually going to start with what I think is the hardest first, which is some word problems. We're going to do 2 or 3 word problems, and then we'll do some partitioning, and then we'll end with time, because I think you all pretty much for the most part have time on lock. I feel like you all are really solid with time and telling time to the half hour and telling time to the hour. Okay. So the first one we're going to do is we practice something like this week. Is there were 20 students on the bus? Some students got off at their stop. Now there are 12 students left. How many students got off the bus? So there were 20 students on the bus. Some students got off at their stop. Now there are 12 students left. How many students got off the bus? So the first thing we're going to start with is an equation. Okay, remember ESA, elephants sing always, equation, strategy, answer. So our first number we have in our problem is the number 20. So I'm going to go ahead and say that 20 is going to start our equation. Now that's not always true, but for first grade, typically the first number is what starts our problem or our equation. So 20 students were on the bus. Some students got off. So if they got off, okay, they got off the bus, they left, we're talking about subtraction. So we're subtracting the sum that got off the bus, okay? And now there are 12 left. Now what you could do is you could do 2 types of strategies. You could do an open number line where when you draw your open number line, you start over here at 20. These are the hops that you're going to do, and this is where you're going to end up. So remember, this is the start, this is the hops, and this is where you end. I'm not going to solve this problem that way. I'm going to go ahead and I'm going to solve this problem a little bit differently. So I'm going to, I accidentally erased my equation. 20 minus unknown equals 12. I'm going to use a part whole model because when I'm solving a subtraction problem, whole minus part equals part. So I'm going to draw my part whole model. Again, though, you could also do an open number line. The only thing I don't really want to see are circles, okay? I'd rather you show that you know like a counting on or counting back strategy. Okay, my whole number is 20, which goes down here, and these are my 2 parts. I do know one of my parts. One of my parts right here is 12. So I'm going to draw 12 circles here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I haven't really pointed this out, but it is easier if you organize your dots in the group. Try to organize them maybe into groups of 5 or 4 or something like that, because then it makes it easier to count them again. I'm going to put 12 in my head to see where I can get to 20. So if I put 12 in my head, 13, 14, 15, 16, 17, 18, 19, 20. Now this is my missing part, okay? So I'm going to count how many green circles I made in here, knowing that this number plus this number equals the whole of 20. 1, 2, 3, 4, 5, 6, 7, 8. So 20 minus 8 equals 12. Okay? 20 minus 8 equals 12. So that is how you solve this type of word problem. Okay? Now, if I did that too quick, or if I'm ever moving too fast, you just hit pause, Mrs. Cooper will freeze, and then you can just learn at your own pace. That's the benefit of a recorded lesson. And I think I've talked about that before. There's some really great benefits of recorded lessons, but there's also great benefits of live lessons. You know, they each have their pros and cons. Okay, so let's do the next one. This one is going to be Vita. Picked some. She picked some flowers. Okay. She picked. Okay. She picked 3 pink, 9 purple, and 7 blue flowers. How many flowers did she pick in all? How many flowers did she pick in all? Okay, so let me get some colors out. Always makes it a little bit easier. She picked pink, purple, and blue. So she picked 3 pink. Okay. She picked 9 purple. And she picked 7 blue. Now the problem is asking for how many did she pick in all? Okay, so when we're talking about how many did she pick in all, we are talking about how many all of these are added together. Okay, so we're looking for the sum of all those numbers. Rather than drawing a whole bunch of circles, there is an easier way to solve this problem. So I don't know if you remember when we were adding 3 numbers together, there's different strategies you can use in order to make the problem easier to solve. So like, what 2 numbers would you add together first to make the problem easier to solve? So for example, I could add 7 and 3 together to make an easy 10. 3 plus 7 equals 10. Then I would continue to bring down the 9 and add 10 plus 9 to get my sum. And this is an easier way to solve this problem. So rather than trying to figure out, oh, how am I going to make a part whole model or an open number line, it's so much more simple to add 2 numbers together that make an easy 10, or make a larger number. You would add these two together. So 3 and 7 added together make a 10. 10 plus 9, that's an easy equation. That makes 19. So then we would know that Vita picked 19 flowers in all, okay? Because she picked 3, then 9, then 7. Adding the 3 and 7 together makes it a 10. Add 10 plus 9, that equals 19. So she picked 19 flowers in all, okay? Again, if I'm ever moving too fast, rewind, pause. That's the benefit of that recorded video. I want you all to panic that I'm moving fast. And the reason I'm moving fast is because I don't have all of you in front of me. So I don't have all of y'all showing me your work and things like that. So that's why I'm moving a little bit quicker, because I'm missing all of you. All right, so we are going to do one more word problem. Okay. So there are some students in the cafeteria. Cafe. There are some students in the cafe. Okay. 4 more come in the cafe. Now there are 13 students. In the cafe. How many were in the cafe to start? So how many students, I know I'm writing fast and sloppy. How many students were in the cafe to start? Okay, so it wants to know how many that were there at the beginning. So that is going to be, this is going to be our sum. There are some. Do we know how many? No. There are some. Okay. 4 more come in the cafe. 4. Okay. 4 more means addition. 4 more come into the cafe. Now there are 13 in the cafe. Now there are 13 in the cafe. How many students were in the cafe to start? Now, we could solve this as a part plus part equals whole. You could also change the equation to subtraction, okay? And that's the same thing. If part plus part equals whole, whole minus part equals part. And if this is part plus part equals whole, you could change this equation. You change the color. You could change this equation to whole minus part equals part. So what I'm going to do for this problem is I'm actually going to solve it this way first, and then I'm going to solve it this way. So I will change it into the subtraction problem. So first, let's solve it using part whole. I'm going to draw my part whole diagram. My whole is 13, and I'm trying to find another part. So my first part that I know is 4. 1, 2, 3, 4. And then what I'm going to do is I am going to count in my head till I get to 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And then I would count how many purple dots are here because this is my unknown. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 4 equals 13. So that's the way to solve it with the part whole. Now, if I'm switching it up, and I'm going to solve this problem as a subtraction problem. Because I remember that my whole is 13. One of my parts, whole minus part, equals, oh, sorry, I wrote part. 13 minus 4 equals unknown. Now for this one, I could do an open number line. Okay? I could do an open number line. So I could start here at 13. This is where I'm going to start. These are how many hops I'm going to do, and this is where I'm going to end up. So I'm going to do 1, 2, 3, 4, and then I'm going to count back until I get to this number here, and that's my unknown. 13 minus 1, 2, 3, 4. Always double check your hops. 13 minus 1 is 12. 12 minus 1 is 11. 11 minus 1 is 10. And 10 minus 1 is 9. Same answer, different way of solving it. So you can solve it in 2 different ways. If you understand how to flip the equation to make it easier and change it from addition to subtraction, do that. If you don't understand that and you were like, Mrs. Cooper, I did not get that, I only understood the part whole model, do that. You still came to the same answer, okay? I'm just showing you 2 different ways to solve it. Okay. So next what we're going to do is we are going to do some, I need to clean my board. Next what we're going to do is we're going to do some partitioning. So let me go ahead and get out some different colors. We're going to do some partitioning. Okay. So you're going to share half of your pie with your friend Egypt. Okay. So you have your pie. You're going to share half of your pie with your friend Egypt. I want you to divide the pie in half and then shade in, color in the piece that Egypt would eat. Okay. So if this is my pie, I'm sharing it with my friend Egypt. It's me and Egypt. Okay. Or you and Egypt. Okay. And I'm going to divide it in half. Okay. This is our pie. I'm dividing it in half. This is my piece. This is Egypt's piece. And I'm going to shade in or color in the part that she would eat. So I divided it in half and I shaded in the part that Egypt was going to eat because I shared it with Egypt and she has a half and I have a half. Okay. That was easy peasy, lemon squeezy. I know you're all like, whoa, we know how to do partitioning, Mrs. Cooper. And then, okay, the next one is that you have a candy bar. And remember how we talked about candy bars? You have a candy bar here. Okay, you have a candy bar. You want to divide it into fourths and eat 1/4. Okay, I would like you to divide your candy bar into fourths. And then I would like you to shade in the part that you would eat. Okay, remember dividing your candy bar into fourths. Okay, if we're dividing this rectangle into fourths, you want it to be shared easily. So if I'm dividing it into fourths, I'm going to divide it into fourths this way. Okay, you divided it into fourths. 1/4, 1/4, 1/4, 1/4 is 4/4. There are 4 parts of one whole. And then you would shade in the piece that you would eat. You want to eat 1/4. So that's the part you would shade in. Pretty easy peasy lemon squeezy. I know we've been talking about this all week, but it's good review. Okay. Next one, what we're going to do is I'm going to show you some times on an analog clock, and then you are going to rate the digital time. So make sure that you pause me so you're not like, oh, Mrs. Cooper, you're going too fast. Okay. Let's do this time first. What time is this in digital form? Good. That's right. The time is 10 o'clock in digital form. I lost my holder. It's all good. Okay, let's do another one. What time is this in digital form? Good. The time is 2 o'clock. Okay. The time is 2 o'clock. Good. 2 o'clock. Okay. What time is this in digital form? Be careful. It's in between the 2 and 3. It's not at the 3 yet. And be careful to where the minute hand is pointing to. What does that minute hand represent? That's right. This time is 2:30. We are not quite at the 3 yet. We're still between the 2 and the 3. We haven't made it to the 3 yet. So it is 2:30. The minute hand represents 30 minutes. All right, let's try another one. What time is this? Yep. Come on, hour hand, work with me. What time is this? Be careful to where the hour hand is pointing to compared to the minute hand. That's right. This time is 6 o'clock. Okay. Now what time is this? Be careful with that hour hand. It's in between the 6 and the 7. It hasn't made it to the 7 yet. Where's the minute hand pointing? So this time would be 6:30. Okay, let's do 2 more. Just random times. What time is that? Hasn't made it to the 6 yet, still between the 5 and the 6. Right, that time is 5:30. Hasn't made it to the 6 yet, halfway around the clock, 5:30. 30 minutes is halfway around 60 minutes. So it's half of 60. Okay. Last one. Oh, come on, Judy clock. Okay. What time is this? It's in between the 11 and 12. Hasn't made it to the 12 yet. So where's that minute hand pointing to? That's right. This time is 11:30. Okay. So that is 11:30. So that is all I have for you today for your math lesson. We did some review with word problems. We did some review with partitioning. We did some review with time as well. We told time based on, I wanted you to read the analog clock and write the digital time. That's a little bit harder than drawing it. So thank you so much for joining me, and I'll see y'all next time. Bye, friends.